Assalamu alaikum, dear student. So today we are going to solve another paper, and the paper is of A level, AS level, and it is 970122. So it's 22 variant and is the series October-November 2020. Okay, so going to start solving the paper. So concentrate. So here in this question number 1, it is mentioned that atoms contain the subatomic particles, electrons, protons and neutrons. Protons and electrons were discovered by observations of their behaviors in electric field. The diagram shows the behavior of separate beams of electrons and protons in an electric field. So you can see this is a simple situation in which we are just passing the subatomic particles, and those subatomic particles are deflecting towards the different directions. Okay, so here we have to mention, and it's clearly labeled, it is electron, and we know that as electrons are negatively charged by itself, so they are definitely deflecting towards the positive end or the positive plate. So we have to say the charge on the plate must be positive, whereas this particle is clearly labeled as proton, and we know that the charge on the proton is positive, so it will be definitely deflecting towards the negative plate. Okay, so this is a simple situation of the diagram. So we have to see what is asked by the examiner. So here in this part 1, it was asked that complete the diagram with the relative charge of each of the electrically charged plates. Okay, so as we discussed here, this plate is itself positively charged as electrons are attracting towards this one, and we know that the opposite charges attract each other, whereas this one is the negatively charged plate, as proton being positively charged are attracted towards this end. So in the next part on the diagram, draw a line to show how a separate beam of neutrons from the same source behaves in the same electric field. So we know that neutrons have no charge at all, so that's why they will deflected in the direct or in the straight way, like in this situation. Starting from this source, you have to draw a straight line. Okay, so you just have to draw a straight line if you want. How? So just I'm going to draw this one. This is the positive negative plate, this one is the negative plate, and here is the source. And we learned that electrons are deflecting in this way, whereas the protons are electing like in this way. So you have to draw a straight line like this. Okay, and you have to label it as neutrons. Clear? Like this. So this is the source, and you have to show. Got it? So now hopefully you understand that. And now moving in B part, electrons in atoms up to krypton, the proton number 36, are distributed. So krypton, the proton number of the krypton is 36, are distributed in s, p and d orbitals. Okay, state the numbers, so number of occupied orbitals in an isolated atom of krypton 36. Okay, so proton number 36, krypton, we have to mention that what type of the orbital it is mentioned. This is s, p and d, and we have to mention the number of orbitals. So you have to keep in mind that each orbital maximum contains 2 electrons. So here I'm going to write the electronic configuration of krypton. This is krypton, proton number 36. So we have to say it is 1s2, then 2s2, 2p6. Whenever we reach to 2p6, it is the electronic configuration of neon. Then 3s2, 3p6, then we have to write 3d, but remember, as the energy level of the empty 3d orbital is higher than the empty 4s orbital, so we have to place the electron in the 4s orbital first. But after filling, its energy level rises, so it could be, or it should be, placed after 3d. Okay, now we have to place the 10 electron in the 3d orbital. Got it? So accordingly, whenever we goes and filling 4s2 3d, then it means we are successfully placed 20 electrons. Then we have to write 4p. So it will be, you can say, the 4s2 20, then 20, then this one are 30, and 30 plus 6, 36 electrons are completed. And as I already mentioned that in 1s we have only one orbital, so it is one orbital as well. Okay, and you have to remember this is also s, so this is 1 as well, and here we have the s orbital as well, so 1. So total we can say 1 plus 1 plus 1 plus 1, so we have 4. The s orbitals are of what? How many? 1, 2, 3 and 4. So total 4 s orbitals we are using. Total 4 s orbitals we are using. Then you have to remember, in p orbital we have, p subshell we have 3 orbitals. As we have 6 electrons, and 6 electrons can be placed in by mean of pairing 3. Okay, so 3 pairs can totally placed in p orbitals. As a whole we can say 6 electrons. So here it is again p, so number of orbitals are in 3p subshell are 3 as well, and in this one also 3. So 3 plus 3 plus 3, so we can say in p orbital p subshell we have 9 orbitals. Then while going, and as we have only one d, and in d subshell d orbital we have 5, d subshell we have 5 orbitals, so we can say the number of orbital in d subshell are 5. Okay, so this is the right answer for the option, or for the question which we are discussing. Got it? So you have to fill up this table accordingly, and you will get 1 mark for each correct number of orbitals mentioning for the s, p and d. Okay, so you have to remember what is the electronic configuration. Even you can go through box notation, and when you go through box notation of the electronic configuration, then you can easily and successfully find out how many different orbitals are there when we are placing the electrons of the krypton in different energy levels. Okay, so here the B part 1 is completed, and now we are shifting toward the second part of the question 1 part B. So here it is mentioned that complete the diagram to show the number and the relative energies of the electrons in an isolated atom of silicon having the proton number 14. So it is clearly mentioned, you have to go through, this is called as the box notation. Okay, so in box notation we have to understand that what is the atomic number of silicon, and it is clearly there. Silicon has the atomic number of 14, so it means it has 14 electrons as well. So we have to say the electronic structure will be 1s2, it will be 2s2 and 2p6. So when we place 2p6, it means we are reaching the electronic structure of the neon. Then 3s2, and so here till this point we place 10 electrons plus 2, so 12. Now we left with only 4, so we have to say 3p4. Got it? But remember, now I'm going to write the box notation as the demand are according to the box notation, and this indicates the rising level of the energies of different orbitals. So 1s is the lower energy orbital, then the 2s which is higher than 1s, and so on. Okay, so you have to write the electronic structure in the box notation in ascending order of their ascending order of energies. Got it? So we can say in 1s we have one box only, and we have to place two electrons, 1 and 1. Then we have 2s. Here again we have two electrons to place, so you can use half arrow or double arrow, it's your okay. So we have to place the clockwise and anti-clockwise direction. So 1s, then one electron is moving, orbiting in a clockwise direction, the other one is orbiting in anti-clockwise direction. Then we have to say 2p. The 2p have some slightly higher energy level than the 2s. So but in the 2p subshell we have three orbitals, 1, 2, and here we have to follow the Hund's rule. One electron we have to place in each subshell, in each orbit first, then according to the Hund's rule we have to pair it up like this. Then we have to say it is 3s. Again we have to place two electrons. Then 3p, as you know, here in 3p orbital we have four electrons. So first of all we have to show the three orbitals, but following the Hund's rule we have to place single electron in each orbit, then we have to pair it up. So only this electron is paired up, 2 remains unpaired. So this is the box notation of filling up the electrons of silicon and showing the electrons of silicon. Got it? Hopefully you understand that. Then in the next part, third part, the diagram shows a type of orbital. We can say as this is the double loop, and we can say a dumbbell or an hourglass shape, so that is why it is of p subshell. Okay, then state the total number of electrons that exist in all orbitals of this type in an atom of fluorine. So again, for fluorine atom we have to draw the electronic structure, and then we have to find in total how many electrons can be placed in the orbital of type p. Okay, so fluorine, the proton number is 9, mean electrons are 9, 1s2, then 2s2, and 2p5. So we can say the total number of electrons that can be placed in the p type orbital are 5. So we can say how many electrons that can be placed in the p type orbital. So this is only 5. So we have just write number 5. The first ionization energy. So here the first ionization energies of elements in the first row of the d block, that is scandium to copper, are very similar. For all these elements it is a 4s electron that is lost during the first ionization. Got it? So suggest why the first ionization energies of these elements are very similar. So this is actually not similar, but is clearly written as very similar. So for this one you have to go through the electronic structure of starting from scandium. Like we can say scandium is proton number 21, and I'm just following the structure like argon, and till argon we placed 18, so we have to say 3d and 4s2. As I said earlier, when you place the 4s2 it means we place 20 electrons, but there are 21, so we have to place only one electron in the 3d. Got it? So we can say the distance from the nucleus to the outermost shell. Okay, so I'm just going to write the last element of the series or given situation, like scandium to copper. So I'm just going for the copper. The proton number of the copper is 29. You can check it from the data booklet, from the periodic table. Then again we are going to write the electronic structure, electronic configuration of copper 29, proton number. So again 3D, but we have to fill up the 4s. But copper has a unique situation in which we have to place the 1 electron over here and the 10 electrons in the 3D. So it is a unique special situation in which the 4s orbitals 1 electron shifted back to have more stable electronic configuration or structure of the 3D subshell. Got it? So now similarly, or what is the similarity, what we are going to discuss, it is you can easily see that the number of inside shells are the same for all the atoms that are starting from 21 to proton number 29. That is why we can say that they have almost similar type of the nuclear pull over the valence shell electrons. So we can say they all have similar type of the nuclear pull for the valence shell electrons. Got it? So first point you can write is the similar type of the nuclear attraction, nuclear pull, okay, or the number of, we can say that the proton charge, we can say even, so is similar, not exactly the same, is similar. Second thing, you can say that the number of electrons removed are from the same energy level. The number of electrons are from the same energy level, that is 4s. So even we can say the electrons are removed starting from scandium 21 till copper 29 are all removing from the principal quantum number 4. The principal quantum number 4. So definitely they are experiencing the same number of the inside electron or inner electron. So we can say the shielding effect over the 4s orbital almost remains the same. It is not exactly the same, but we can say it is almost the same. So keeping this in your mind, what should we have to write? Here it says suggest why the first ionization energies of these elements are very similar. So first valid point we may write is they all experiencing the similar type of the nuclear pull, because the electrons are all removed from the 4th shell, or we can say from the 4s orbital. Third, the shielding they are experiencing, the 4s electrons are all experiencing the same number of inner shell electrons, having same number of the inner shell electron, so they have similar type of the shielding. Got it? So these are the 3 valid points which you can suggest. Now moving towards the C part. In this C part it is clearly mentioned hydrogen is a general term used to represent the ion H plus 1, H plus 2, H plus 3. So 1, 2 and 3, these are the nucleon number. 1, 1, 1, these are the proton numbers or the atomic number, and all have 1 plus charge, mean their only electron is lost. So state in terms of subatomic particles in the nucleus. So it is clearly mentioned in the nucleus. What is same about each of these ions and what is different? So similarity, all of the 3 ion H11 plus, H12 plus and H13 plus have same number of the protons. So we can say they all have same protons in the nucleus. Got it? Then the difference is that they all have different neutrons. Though this one, the H1 plus has no neutron, H12 has 1 neutron, and this one has 2 neutrons in the nucleus. So similarly, or in the simple words, we can say that the similarity is all these 3 particles have same protons but have different number of neutrons. So this is very simple situation. Hopefully you understand. Now moving and going to discuss the question number 2 of the same paper, that is October-November 2020 series 970122. So in this second question, the period 3 elements sodium to sulfur all react with oxygen to form oxides. State. So and here we have to state the trend in acid-base behavior of the oxides of period 3 elements from sodium to sulfur. So we can say that sodium being metal form metallic oxide, and we know that the metal oxides are basic, whereas the sulfur being a non-metal form a non-metal oxide, and the non-metal oxides are acidic. So we can say that the trend of, we have to state that acid-base trend from sodium to sulfur, the behavior of the oxide is from acidic to basic, changes from acidic to basic. So behavior of the oxides of sodium to sulfur are as changing from acidic to basic. And you can explain, but there is no situation to explain, as we have to earn only 1 mark. So we just have to mention that the behavior is changing from acidic to from basic to acidic. Got it? But you have to keep in mind the explanation that sodium is being a metal form basic oxide, whereas the sulfur being a non-metal form acidic oxide. So in B part of the same question, state and explain. Now we have to explain as well. Here we have to state and then we have to explain the trend from sodium to sulfur in the maximum oxidation number of the period 3 elements in their oxides. So as it is clearly mentioned, the maximum oxidation, so we know that what is oxidation? Oxidation is the number of electrons involved by an atom in a bonding situation, in a combined situation with other atoms, or other elements. Got it? So as the number of electrons are increasing, that is why the oxidation state is increasing. So first of all, we have to mention, we have to follow the situation, we have to state what is the trend. We can say the oxidation number is increasing from sodium to sulfur, and the logical explanation is that as the number of valence shell electrons are increasing from sodium to sulfur. So simply we have to write only these 2 points. The oxidation state is increasing from sodium to sulfur due to the increase in the number of valence shell electron from sodium to sulfur. And you know that sodium belonging from group 1 have 1 electron in its valence shell, magnesium is of the 3rd period have 2 electrons, aluminium have 3, silicon has 4, then phosphorus has 5, and the sulfur has 6. As the number of valence shell electrons are increasing, that is why their oxidation state is also increasing. Then in the C part, what we have to say, sodium oxide and phosphorus 5 oxide both react with water. Name the product of each reaction. We can say sodium oxide with water. So being as we discussed earlier in this question, the sodium oxide is a metal oxide, and group 1 metal oxide can very easily be dissolved in water, forming sodium hydroxide. The second one is phosphorus 5 oxide in water. So non-metal oxide when dissolved in water form acidic solution. So here in this situation we can say phosphoric acid is formed. So I have to show you by writing the equation. So I'm going to write the equation to show and to explain what is actually happening. As I mentioned, the metal oxide, this is Na2O, sodium oxide. When we try to dissolve in water, it will produce NaOH aqueous. So, and we know that it is strong alkaline. Okay, so if the pH is demanded, we can say it will be above 11 till 14. So we have to mention any value that is from 11 till 14. Got it? The next thing is we have P2O5, and when we try to dissolve this one in water, it produces H3PO4. The oxidation state remains the same. In phosphorus, the oxidation state is +5. In phosphorus 5 oxide, the oxidation state is +5. And also in phosphoric acid, the oxidation state of phosphorus remains the same, which is +5. So it is just dissolving. Okay, and as this one is a weak acid, so we may write the pH value that is closer to 3 or higher than 3. But look what is demanded next. So here we just have to write the product, what it is, NaOH aqueous, and here we have to and clearly mention that this is the name. So try not to write the formula. You are supposed to write the name. This is aqueous sodium hydroxide, and here we have to write phosphoric acid. Got it? Aqueous. So then in D part, explain why phosphorus 5 oxide has a low melting point of approximately 300 degrees Celsius, but magnesium oxide has a high melting point of approximately 2850 degrees Celsius. So it's very simple. So it's of 3 marks. First mark you have to get that by writing the magnesium oxide has a giant ionic structure with strong forces of attraction. The second mark you will get by writing the phosphorus 5 oxide has simple molecular structure with weak intermolecular forces of attraction. And the third mark you definitely earn by comparison, and you can say that is why the magnesium oxide needs more amount of or higher amount of energy to be melted as compared to the phosphorus oxide, phosphorus 5 oxide. So I'm repeating again, you have to write that just magnesium oxide has a giant ionic structure with strong forces of attraction, whereas the phosphorus 5 oxide has simple molecular structure with weak intermolecular forces of attraction. Therefore, magnesium oxide needs a higher amount of energy or a high amount of energy to be melted as compared to the phosphorus 5 oxide. Hopefully you understand. Okay, so now proceeding towards the next part of the same question, and it is the part E on page 4 of the same paper. So aluminium oxide Al2O3 reacts separately with both acids and alkalis. So we know that anything that is reacting with both acids and alkali have amphoteric nature. Got it? So amphoteric means anything that has the properties of both acid and bases. So the demands of the question are: write an equation for the reaction of aluminium oxide with excess of aqueous hydrochloric acid. So what we have to say, what we have to write as an equation. So this is Al2O3 when it is reacting with HCl aqueous, and as this is a metal oxide, must be having high melting point, so it should be a solid. Then it produces AlCl3, and then along with, as the acid base reaction is taking place, so it will get aluminium chloride and water. Got it? So you have to write this equation. Next thing is, write an equation for the reaction of aluminium oxide with excess sodium hydroxide. So in the previous paper we have the same type of the question, but in that we discuss about the gallium. Okay, hopefully you understand and you learn and you have in your mind. So here this is Al2O3 reacting with NaOH when alkali and acid, as now it is behaving like an acid, being reacting with the alkali, so it will produce NaAlO2 plus water. So this is sodium aluminate. This is sodium aluminate. Now you have to balance. As I forget to balance, you have to balance it. We have 2 aluminium over here in the first equation, so we have to place 2 over here, and as a result we got 6 chlorines. To balance this out, we have to place 6 with the HCl, and now to balance the hydrogen we have to place 3 with the water. Now in the second part, as we have again 2 aluminiums, to balance it out we have to place the 2 with sodium aluminate. To balance the sodium we have to place 2 over here. Now hydrogen is already, or before placing anything it can be seen that it is already balanced. So hopefully you understand. Then in F part it is mentioned that describe the lattice structure of silicon 4 oxide, and remember that the silicon 4 oxide is a macromolecular structure as a giant covalent structure. So here is the instruction. You have to follow the instruction as well. Try not to write the answer in a general way. Try to follow the instruction which are given. So the instructions are: your answer should include reference to the arrangement of the silicon and oxygen atoms and the bonds between them. So as the marks are 2, so we are just going to mention that in silicon 4 oxide each silicon atom is directly bonded with 4 oxygen atoms, whereas each oxygen atom is directly bonded with 2 silicon atoms. Like I'm going to show you the structure here. You have to write the tetrahedral nature of the silicon. Here you have to place O, O and O, and as I claim that each oxygen atom is directly bonded with silicon, so we have to write like this. Got it? So you can see that this is the one silicon atom that is directly bonded with 4 oxygen atoms. Now to justify this one we have to extend this, as here we have to place the oxygen again. Then so now you can see each oxygen atom is directly bonded with 2 silicon atoms. So this is the situation which you have to justify by writing each silicon atom in silicon 4 oxide is directly bonded with 4 oxygen atoms, whereas each oxygen atom in silicon 4 oxide is directly bonded with 2 silicon atoms. So you may draw the diagram, but it is not needed. You just have to write in words. Hopefully you understand. Now in the G part, sodium oxide and silicon 4 oxide react to form sodium silicate Na2SiO3. Sodium oxide is obtained from the thermal decomposition of sodium carbonate. So write equation for the following reactions. Number 1, sodium oxide with silicon 4 oxide, and as we discussed, the silicon 4 oxide being non-metal oxide is acidic, so it can very easily react with the sodium oxide which is basic. So as a result we will get Na2SiO3, sodium silicate. So this is sodium silicate. In the second part it was demanded that the thermal decomposition of sodium carbonate forming sodium oxide and carbon dioxide. So instructions are clearly there. What we have to say, the sodium carbonate, the formula is Na2CO3. Generally we know that group 1 metal carbonate doesn't decompose, but as the instructions were there, so we have to write the equation accordingly, and we get Na2O metal oxide and carbon dioxide gas. So the equation is already balanced, you can check it. So proceeding now, here the question number the question number 2 was completed, and here we have to go for discussion of question number 3 of the same paper at page number 6. Got it? So here in this of the same paper we are discussing question number 6. So PCl5, PCl3 and NCl3 are halides of group 15 elements. So remember, group 15, either we are going to write it as group 15 or group 5, similar to the nitrogen. Okay. So PCl5 can be formed from the reaction of phosphorus with chlorine. PCl5 has a melting point of 161 degrees Celsius. Write an equation for the formation of PCl5 from the reaction of phosphorus and chlorine. So again, the instructions are clearly there. We just have to write the equation. The phosphorus is reacting with chlorine and producing PCl5. To balance this out, we have to take 5/2 chlorines. And even if you are going to choose P4, you can also write the equation like it will be PCl5. But to balance out this, we need 4 phosphorus, so we have to place 4 here, and 5 4s are 20, and to get the 20 chlorine atoms, we have to write 10 over here. Got it? So either way you can write. Okay, it's your choice. Then in the second part of the same question it is, state the type of structure and bonding shown by liquid PCl5. So we know that this is simple covalent, or even we can say that it is covalent bonding. We can say that it is covalent bonding. So now proceeding, for the B part, a small amount of PCl5 is added to excess water, and the PCl5 reacts vigorously to form a colorless solution. Give one other observation you would make when PCl5 react with the excess water. So simply, just I'm going to write the equation first for the reaction of PCl5 with water. So as a result, we can say hydrolysis take place. The PCl5 molecule splitted into 2 parts. The one is H3PO4 and the other one is HCl. And whenever you found the formation of HCl, so we can say the white misty fumes observed. White misty fumes observed. So this is the other observation. Next is, write the equation for the reaction of PCl5 with excess water. So here the equation we already mentioned. When PCl5 react with the water, it will get phosphoric acid and hydrochloric acid. So to balance this out, as we need 5 chlorine over here, so we have to write 5 over here. So you know that 5 plus 3 hydrogen 8. To balance this out, we have to place 4 over here. Now the equation is balanced. So now in the third part, estimate the pH of the resulting solution. And as we write it the equation, and we know that there is HCl, which is a strong acid, phosphoric acid, which is also weak acid but having the lower pH, so we can suggest any value between 1 to 3, and I advise you to write 1 value. Okay, so moving towards the C part of the same question, here you can say PCl3 is used to convert alcohols to chloroalkanes, such as compound T. Here we can say this is dichloro, and the number of the atoms that are connected to the chlorine, so you have to count it to get the complete name. So I'm not going to write the name, just going to check what is happening in the question, in the reactions. A possible synthesis of the T is shown. Here first we have the carboxylic acid and alcohol. So this is hydroxycarboxylic acid. When it goes through under reaction 1, we get the primary alcohol again. So we can say what is happening here, the reduction is taking place. Here what is happening, the reduction is taking place, and we know that when we reduce the carboxylic acid, it will get or converted into the primary alcohols in presence of a strong reducing agent, that may be lithium aluminum hydride in dry ether. Next, by using PCl3, we can say that the PCl3 is usually used for the substitution process, and this PCl3, the Cl nucleophile is substituting the hydroxide nucleophile, hydroxy nucleophile from here and from here. As a result, we get the compound T. As a result, we get the compound T. So here what is happening? The nucleophilic substitution is taking place between the chloride and the hydroxide nucleophiles. So the demand in this first part, identify a reagent that could be used in reaction 1. As I claimed earlier, the carboxylic acid is converted into the primary alcohol, so it is only happening by the reduction. Okay, and for reduction we have to use lithium aluminium hydride. How to write? LiAlH4 in dry ether. Dry ether is the inert solvent in which we have to dissolve it. So we have to write this one is a strong reducing agent. This is what? Strong reducing agent. Hopefully you understand. So now proceeding towards the next part of the same question, and it is the second part. So here T exhibits optical isomerism, and we know that what is mean by optical isomerism? When any molecule that contains a chiral carbon atom and form non-superimposable mirror images. So we can say this is the optical isomerism. So here we have to say explain what is meant by the term optical isomer. So we can say a molecule or the molecules which are non-superimposable mirror images of each other. Got it? So those are called as optical isomers of the each other. And then he said that and circle any atom or atoms in T that give rise to the optical isomerism. As I said that the optical isomerism arises due to the presence of chiral carbon atom, and chiral carbon atom means the carbon having 4 different atoms or groups. So if we are talking about this carbon, or I'm going to draw it for you here, this molecule can be drawn in a displayed situation like this one is the CH3 that is bonded with C, which is also bonded with CH3. Here we have Cl that is further bonded with C that has 2 hydrogen atoms. Then this is C. Here we have CH3 again, and then we have 1 hydrogen, and here we have C, H, and that is bonded with Cl. So this is the displayed, semi-displayed situation that reveals where we have the carbon atom that is or that has 4 different groups or atoms. So we can say this one is the only carbon atom in this molecule that is bonded to 4 different groups. Like this one is the different group to this one, which is in turn a different group to this one, and as the hydrogen atom is the different one as well. So this carbon atom is directly bonded to 4 different groups or the atoms. So that is why this is chiral carbon atom, and it can be we can say for non-superimposable images, mirror images, and is called as the optical isomer. Clear? So then in the next part, T is a minor product in the reaction of compound S with excess HCl. So then this is the S. Draw the structure of the major product of the reaction of S with excess HCl. So here what we have to say, this is the molecule of, I'm going to write that S here, double bond and double bond. So this is S, yes, and when it goes and reacting with the HCl, we can say it is going through the electrophilic addition mechanism. This is partial negative charge, partial positive charge. The double bond can easily attach to this carbon, and this bond will be withdrawn can be withdrawn by chlorine atom. Same is the case when it is reacting from this end with hydrogen that is bonded with Cl with a partial negative charge, with a partial positive charge. The double bond, we can say the pi electrons are attacking on the hydrogen, which is partially positive charge, and then this electron is being withdrawn by the chlorine. So as a result, we get an intermediate like this. Here the double bond is broken, and according to the situation, the hydrogen is attached to the carbon which have more hydrogens. So here we get the CH3 group. And as in the skeletal form, we are not required to write the hydrogen atom. So hydrogen atom is attached to this carbon atom, remember, this carbon atom. And then as there is a deficiency of the bond electron, so this carbon atom will acquire a complete positive charge. Same is the case with this type. Here the hydrogen is attached to this carbon atom, and in the response this carbon atom will acquire a positive charge. And by the result of this electrolytic fission, one chloride ion with a complete lone pair of electron, or even I can write over here one chlorine atom with electronic pair. Here also one chloride ion with one extra lone pair now form that can easily attack to this carbon atom, that can attack to this carbon atom, and as a result we get this type of the compound. Here we have Cl, here we have Cl. So I tried my best to show the complete situation, and this will give rise to the major product. And the minor product is also there, like this is the minor product. You can see clear? Hopefully you understand. Now the next situation, and even it is clearly mentioned that if we are reacting it with only one HCl, we are going to react it with only one HCl, then we can get, or the double bond of the one side is only broken now, but we have to write both. So hopefully you understand. Now proceeding towards the next part of the same question. Here it is mentioned that NCl3 is a yellow liquid that can be used to bleach flour. Predict the shape of the NCl3 molecule and the Cl-NCl bond angle. So for that we have to simply draw the Lewis structure. Like here nitrogen is there and is making the structure like this. So here chlorine is bonded, chlorine is bonded, chlorine, and nitrogen being, the nitrogen being from the group 5 have one extra lone pair of electron. Here we have to write like this, and then you can easily check that what type of the geometry this molecule has. So it is clearly seen that this has trigonal pyramidal. This is trigonal pyramidal, and the bond angle is definitely 107.5 degree. Hopefully you understand that. In the next part, the second part, NCl3 react with water to form HOCl, a weak Bronsted-Lowry acid. Explain fully what is meant by the term weak Bronsted-Lowry acid. So first of all, you have to mention what is acid. We can say the proton donors are acid, and for the weak we can say that which partially ionizes when dissolved in water. So we can say that proton donors are the Bronsted-Lowry acids, and when dissolved in water it partially ionizes. That is why it is called as weak acid. Then in third part, NCl3 decomposes according to the equation shown. A sealed container of volume to 50 cm3 contains an unreactive gas at a pressure of 1 × 10⁵ Pascal. Then 0.241 gram of NCl31 was injected into the sealed container. The sealed container was heated, make the NCl3 decompose fully. So first it was partially decomposed, and the situation was there, the initial pressure we have. Then the sealed container was heated at a temperature of 20 degrees Celsius. So we have to calculate the final volume. So what we are going to do here, we have a simple situation. Like examiner asked us to write the total pressure. Initially we have P1 and then we have to add P2. The value of the P1 we already know from the situation, like you can see here. This is 1.0 times 10 raised to the power 5. 1.00 times 10 raised to the power 5. Got it? But we don't know the P2. So to find out the P2, we are just going to apply the formula PV equals to nRT. And now we have to substitute the value, and as we are interested to find the P, so that is why we are going to keep separating P from the other part, so it will be nRT over V. Now as we have to convert the values, like we can say here we have the mass of NCl3, so the mass of NCl3 must be converted into the moles, which is N equals to mass over mR. Okay, so the mass of the compound of NCl3 was 0.241, so we have to divide it 0.241 divided by the mR of the NCl3. We have 1 atom of nitrogen plus we have 3 atoms of chlorine. The atomic mass of chlorine is 35.5. So we have to solve, and then we get the answer. So I'm going to calculate it. As a result, what we have to say, what should be the answer? The moles, we can get the moles that are 0.0040. You can do it by your own calculator as well, as I'm going to use a simple calculator, not a scientific one. So the next thing which we have to convert the units, we must need the volume must be in meter cube, and as the volume here we have, it is 250 centimeter cube. To convert this 250 centimeter cube volume into meter cube for using in the general gas equation, what we have to say, we have to multiply it by 10 raised to the power minus 6. As a result, it will be converted into a meter cube value. Then we have a temperature that is 20 degrees Celsius, but we have to convert it into the Kelvin scale, so we have to add by 273. As a result, we get the value in Kelvin scale. Got it? So, and we have the R, that is a general gas constant. It is provided in the data booklet and its value is 8.31. So now we have to replace all values, and as a result we will get nRT, that is 0.0040 times the value of R is 8.31 times the value of T, 20 plus 273, it is 293, divided by the volume, it is 250 times 10 raised to the power minus 6. And when we do this, you get the value, like we have to calculate it. So you have to use your own calculator. Got it? So I'm just calculating. So multiplying 0.0040 times 8.31 times 293 and dividing the whole answer by 250 times 10 raised to power minus 6, and here we have the answer, and it is 3.90 times 10 raised to the power 4 Pascal. Okay, as the SI unit or the unit using in PV and RT is Pascal. So now we have to put this P2, we may say this is P2. So this P2 is put it in the first situation, it is 3.90 times 10 raised to the power 4, and then we can get the final answer. For this we have to do the situation again. So by using the calculator, we are going to add with the answer the 1.00 times 10 raised to the power 5. So the final answer we get, it is 1.39 times 10 raised to the power 5 Pascal. Okay, you can use your own calculator to get the final answer. Hopefully you understand. You can check the working how. So this was the first situation. Then you have to apply the PV equals to nRT to get the P2. You have to just get the value of N by dividing the mass with the MR of the compound. Then you have to convert the volume that was in centimeter cube into the meter cube, and then you have to convert the degree Celsius value of the temperature into the Kelvin scale, and then finally you have to replace or put the value of the general gas constant, that is 8.31. When we substituted, we get this value, and then we substituted this value over here to get the final answer. Okay, so this was a very long question of total marks of 17. So now proceeding towards the next question, that is question number 4. So in this question, some reactions of compound G are shown. Here this is the G, and we can say that this is the primary alcohol and here is the aldehyde. So in reaction 1, the G is going and converted into the acid and the acid. So the both end we got acid. So alcohols, the primary alcohol can be converted into the acid by oxidation. The aldehydes can also be converted into the we can say what? We can say that they converted into acid as well. Yes. So this is aldehyde and this is acid. So the conversion of the aldehyde into the acid is oxidation as well. So what is happening over here? This is the, we can say that conversion of the aldehyde and the alcohol into the acids. Then in next stage or the next reaction, Na is reacting, and remember that sodium only can react with the acid and with the alcohols but not with the aldehydes. So as a result, hydrogen gas released. Got it? And in reaction 3, the Tollens reagent is used, which is the oxidizing agent for, which is the reducing agent for the aldehydes. Okay, so as a result, oxidizing agent itself reduced but oxidizing the aldehydes into the carboxylic acid. Alcohols remains the unchanged, but the aldehydes can easily be oxidized by the Tollens reagent. Then this alcohol and acid containing group is heated in presence of the sulfuric acid, so it will self-condensed. This molecule gets self-condensed by the removal of H from the alcohol and by the removal of the OH from the acid and into this cyclic molecule. Whenever, keep that in mind, whenever a cyclic compound is formed, so this is due to the self-condensation. This molecule is self-condensed. How? I will show you inshallah. If there is no demand, then I will show by myself. If there is a demand, then definitely it will be covered in the question. Then in A1, state the type of reaction that occurs in reaction 1. So as I already mentioned, this is oxidation. Suggest the reagents and conditions required for reaction 1. So we can say that we can use potassium dichromate acidified, heat under reflux. Acidified potassium dichromate, heat under reflux. As the aldehyde, we need a mild oxidizing agent, so that is why we are choosing potassium dichromate acidified in presence of heat under reflux. Then in the third part, it is claiming that draw the structure of the organic product H from reaction 1. So as I already mentioned, this molecule is going to react with the sodium and only the alcoholic part can react. Here we have the aldehydic part, then one carbon over here, second, third, and here we have the OH. So when it reacted with Na, so what happens? This compound is converted, the aldehydic part remains unchanged, 1, 2, 3. and then here we have O that is converted into the O negative part, and the sodium is connected along with like this. So this is the H. As a result of reaction, we get the hydrogen. To balance this out, we have to take half with this. Okay, then as it is only demand of the product of the reaction 2 and the organic product, so we just have to write the structure over here. This is the structure which we must have to write. This is H only, the organic product. Then state what you would observe in reaction 3. So here is the reaction 3, the Tollens reagent. As I said that it formed a silvery mirror, and if the reaction is not perfect, we may get a gray precipitate as well. So perfect answer for the situation is, we can say silver mirror is formed. Otherwise you may write it as gray precipitate formed. If the reaction doesn't go perfectly, then only gray precipitate are formed. Then give the type of the reaction shown by reaction 4. So the reaction 4 is condensation. As I already mentioned, this molecule is self-condensed by the removal of water molecule. So that is why this is called as condensation. So this is the type of the reaction, condensation. Then in next part, G and J are the structural isomers of each other, G and J. Got it? Only the position of alcohol is changed. Here the alcohol is at carbon number 3, as the aldehyde group got more priority. Got it? So then this one is to the number 1, 2, 3, third carbon. So this is at carbon number 4 and this is at carbon number 3. Got it? So name the type of the structural isomerism shown by this. So this is called as position isomer or positional isomer. This may be called as position isomer or positional isomer. Suggest one chemical test that can distinguish G from J. Give the result of the test with each compound. So we can say that this one is aldehyde, so both contains, and both also have the alcoholic plus G is a primary alcohol, whereas the J is secondary alcohol. Got it? We can say that the G is primary alcohol, whereas J is secondary alcohol. Got it? So how to distinguish between these two? Here you can say that the molecule that is J, here I'm going to write the structure first so that I can explain, and the displayed formula as well. For the J it is C double bond H, then here we have CH2, here we have CH, then O bond H, and then here we have CH3. And for the G it is C double bond O bond H, CH2, 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 and we have OH. And you can easily check that in these two molecules we have a difference of this situation. Here we have that is called as CH3CO group. So here we can easily find the CH3CO group that can very easily react with aqueous alkaline iodine. Okay, so when we react this molecule with aqueous alkaline iodine, due to the presence of this structure, we get the iodoform. We get the what? Iodoform, and this is a yellow precipitate. This is a yellow precipitate. So what we are going to say, but we can't find CH3C group in G. This is G and this is J. So we can't find CH3CO group in G, but we can find the CH3CO group in J. So that's why we can say we have to choose aqueous alkaline iodine. So when it is reacted with this J molecule, J isomer, So it will form iodoform, and iodoform is a yellow precipitate. So what we are going to say, suggest one chemical test. So test we have to write add aqueous alkaline iodine. So we have to say add aqueous alkaline iodine. Result with G, we can say no visible change. Result with J, we can say yellow precipitate form, and in bracket you can write the explanation of the situation. The iodoform is CH3I. So due to the formation of iodoform, yellow precipitate can be observed or can be seen. So now proceeding, in the reaction scheme below, G and J are converted into organic compound K. Here is G, that is sodium borohydride. We can say this is a weak reducing agent. So G can easily be reduced into the primary alcohols. So here we have the alcohol on the both ends. Then aluminium oxide, it is a dehydrating agent, and as a result the water molecule is eliminated and we get the alkenes. We can get K, which must be alkenes. Here again happening the same, both are reduced. J is also reduced by the sodium borohydride, and as a result we get alcohols, the secondary and the primary alcohols. The aldehyde is converted into primary alcohols. The secondary alcohol remains the same as it is not further reduced. Okay, so then what is happening? Again we are using the elimination process or using dehydrating agent, that is aluminium oxide. So as a result we get alkene, double bonded containing molecule. State the role of the sodium borohydride in this reaction. We can say it is acting as a reducing agent. It is acting as a reducing agent. And then in 4, identify the organic product K. So I'm going to write the situation for you. Here you have to check it out.